All right, thank you. Good, so last talk before the coffee break, right? So better don't go over time. Well, let's jump straight into my talk. So as you can probably guess from my title, we are going a bit deep today into building Angular libraries.
Fuck.
And I would like to start straight away with the question, why? So why do we actually want to build libraries? I think it's from some point quite obvious in the sense that if you build an Angular application today, normally it's being like you have your own JavaScript files, you have your components and stuff, but you also have a lot of external libraries, and they are kind of the building blocks for your application. Like you assemble them together, and you build something bigger out of it. And so, for instance, if you search for something like a fancy drop-down list or select box like this one, then right now chances are quite high if you search them up on Google that you come across this kind of guy, right? I don't know how many of you know that. They have still a lot of plugins and widgets around. And they have also widgets built by the community mainly. So that's a really nice property, which we actually also would like to have for Angular, right? For Angular 2 and onwards. And so we don't, however, just want to optimize for the quantity, of course, but we also want to have a healthy ecosystem, so good libraries which are of good quality, right? Great, so who am I? I'm Juri Strumpflohner. I'm a Google developer expert in web technologies, specifically in Angular. I'm coming from South Tyrol, Italy, so it's in the middle of the Alps. And I'm currently working at a company there called R3GIS. We are in the spatial data system, so basically we do web technologies with geographic information systems. I'm also an Acad.io instructor and freelance trainer and consultant. If you want to join me online, these are the kind of places where I'm around, so it would be cool to see some of you also on there. Cool, so let's get back. We were talking about quality, right? So what does it actually mean to build a good quality library? And so Minko wrote a blog post about a year ago, more or less, and he said a good Angular library should have these kind of properties. So it should be platform independent, which really means like it should be able to run in web workers or on server side, as we have just seen before, on Universal. It should be properly bundled and also distributed, so it can be built in and get into your application. And it should, of course, work with AOT. Like that's kind of the thing you want to do when you go into production, right? Like many of you probably still use JIT in development mode, but that's going to change now with the latest versions of Angular as well, with the Angular CLI. And so that's going to be the default. And finally, it should play well with TypeScript, because TypeScript is like the first class citizen now in Angular, and it has a lot of advantages. And when I bring in an external library, I obviously want to get out completion and compile time checking for that library as well. But that's actually not enough, okay? We've just seen in the talks before, there are a lot of toolings in the Angular system, in the Angular ecosystem. So therefore, our library might be bootstrapped actually by these kind of different tools. So it might be bootstrapped by System.js, it might be bootstrapped on the server side by Node.js, as we have just seen in the talk before. It's probably most a common case now that it is being bootstrapped by Webpack, or someone might simply take your library and just kick it in as a script tag in your browser. So it should work also as a UMD format. And so therefore, our library should be basically open to be statically analyzable. So that means basically tools should be able to read the source code of our library, to understand it, and then to apply optimizations such as tree shaking or dead code elimination. And these are really important because we want to downsize the bundle, okay? And if you're interested in that kind of stuff, I highly recommend to check out the talk by Igor, which he gave at ReactiveConf this year, and where he really goes into those details. So how to optimize an application for the time to interactive, and it's really an interesting talk. So, shipping a library like that is something you often see, but it might not be the best we can do. So at least not in all kind of scenarios. So let's have a look. So what does it mean to have a nicely structured library? Luckily, we have something that's called the Angular package format, and it's right now in version 5. And it's available as a Google Doc online. So you can just search it up on Google. It's publicly available and it's open, so you can go through it. And it is actually some kind of a set of guidelines and best practices which the Angular team itself developed and uses for distributing basically the Angular core packages. And so therefore, if you apply those same principles on your own library, you're basically quite safe. So meaning your library will well integrate in the whole Angular ecosystem, so by those various kind of tools which run there. Great, and so one of the goals here is basically of that package format to support the tools which we just have seen, but also to optimize for the bundle size and for the build time. And especially the latter one is really important because it's often not that much given attention to. But if you think about it, if your application really grows and gets larger and your build time increases, that really drains the developer productivity. So it should also be something that we should take a look at. Okay, one hard requirement, all ESM, okay? We now have the ECMAScript modules, they're really nice to use. So what we would like to have is files like that, where we have import statements and export statements, because that's one of the prerequisites for having that capability of being able to statically analyze your code and to optimize it. Okay, so what does that mean in practice? Let's have a look. Like, I have here kind of a small, really demo application with a tabs component inside there. And the tabs component is actually quite a good candidate for being taken out and distributed as a separate library, right? Now, we'll have a look now, but I'm not as brave as Uri and Pascal, so what I will do is what I call screenshot-driven development, because what could possibly go wrong? So let's create a dedicated library project. I take basically the source code of my tabs component out of the existing application. I set up a new project, and I copy it into the source folder there. So you can see we have our Angular module, we have the different kind of components, and the HTML file, and so on. Now, if you take a look at the package JSON, there's actually not that much of specific stuff or interesting stuff. The only thing I would like you to pay attention to is also the peer dependencies. Those are basically the kind of requirements the application that consumes your package has to satisfy. So if you build something that's only valid from Angular 5 onwards, then obviously you have to specify that here in the peer dependencies. But of course, you would like to keep that as open as possible, right? So that it can be consumed by most people. Then the next thing is the public API TS file. So this is kind of the entry point to our library, where we expose everything that should be publicly visible outside and consumable. So it's kind of a naming convention or kind of a style guide that you have that public API file, and from there everything starts. And as you can see, it basically takes in a file from the source folder. So if we jump there, we see I have here inside the source folder another file, which is I called here tabs.ts, and which then again exports all of the files which are inside that source folder. So in that way you can nicely structure also if you have different kind of modules in there. So before we jump right into the compilation step, we have to do some preparation steps before. And that's mainly for inlining assets. So if you take a look in my library here, I followed basically the style guide. So I have the HTML file and CSS file as external files. Especially if they get huge, it's quite comfortable to have that. And I basically reference them via the template URL and styles URL in my component, right? But that's not quite ideal. Like it's good when you develop, but it's not so ideal when you distribute the package afterwards. So what we want to have actually is to inline it inside the package. And right now there isn't really a standard on how you should do that. So what I did, for instance, is I created a simple script file here, inline assets, and I kicked in a bunch of tools, in this case inline ng2 template, which is quite handy. I specify here the source and destination directory. Like the destination directory is kind of important because I basically move all of the files when they are processed into a temporary directory, and that will be my working directory basically where we do the compilation stuff. In this kind of way, I avoid messing up my source code. Cool, and then basically I pipe it through that inline ng2 template, and then we will get basically a result afterwards out of that compilation step. So for convenience reasons, of course, I specify here a script in the scripts section of my package JSON, so build inline. I also copy over the TS files, as you can see, so I do an rsync before. But the more important part is that just below, afterwards, that's basically invocation of the node inline assets. Right. So if we execute that now, what we get is basically a temp directory with all of the source files in there. And you can now also see that basically that script inlined all of the templates there. It also was so intelligent to use now the template property and no more template URLs property. And so we have everything nicely prepared. Cool. So we talked about tools. And right now, those tools which we would like to support are more or less these kind of tools. So those are specified by that Angular package format. And you can see at the very top, which we are going to start with, is Webpack optimized, meaning it reads the ECMAScript 2015 code, so it has been augmented with some kind of plugins. And the Google Closure compiler, which is going to be more and more important also in the future. And what they require is basically what they want to consume in order to run in the most optimal way is ESM and ES 2015. So ECMAScript module with ECMAScript 2015 code. So let's have a look. let's compile to ESM 2015. Now what we do as a first step is we create such a tsconfig file. It's not the one which we use for TypeScript, it's one dedicated for just doing that build process. And if you have a look, here we have our entry file, okay, the one I mentioned before, so that will be the entry point for the compilation, and then the tools will follow along that entry file and all the import statements and know how many files have to be bundled into the library. Then above there are just the normal TypeScript configurations, like here we obviously want to generate declaration files because we said we want to support TypeScript also in our library. So with that we generated the declaration files. Then for the module we said we always consume ECMAScript 2015 modules, and the target will be ECMAScript 2015. So in this case means we just compiling away the types. And finally we have here the out dir and the root directory. So as I said, the working directory is the temp folder, and out dir will be the ESM 2015 folder. And that as well is something the package format specifies. So in the ideal case, those kind of source files should finish up in a folder called ESM 2015. All right, then you might wonder about this section here below. So this is kind of an extension, because we are not going to use the TypeScript compiler directly, but we are going to use ngc. And ngc is basically the Angular compiler, which wraps the TypeScript compiler, so we don't have to execute both of them. But ngc will also execute tsc. And ngc will basically listen to these kind of settings below here. So it's an extension of the TypeScript configuration here. For instance, here it will generate the annotations for that Clojure compiler, which we want to optimize for. So it will convert TypeScript annotations to Clojure compatible annotations. And we also see here some kind of settings like skip template code generation. So that's for the AUT mode. But actually we don't want to do the AUT compilation right in our library, but that's something the application which embeds our library should do for us. We just want to be compatible with that compilation, right? Cool, and then it generates that metadata file. And that metadata file is actually the one that is being used by AUT. Okay, so again, we add here a script tag in our scripts section, build ESM 2015. As you can see, I use the ngc compiler, and I pass in a configuration file. And if I execute that, we get here in the temp folder the source files. And as you can see, we have here basically the import statements and everything. So it's still basically ECMAScript 2015 modules. And below we have ECMAScript 2015 code because we have the class statements and export statements and stuff like that. And also further down, you can see how it generated also the annotations for the Clojure compiler. Now in this case, I actually wasn't so good in developing that part because I actually did not specify TypeScript types on there, but otherwise they would have been converted. And finally, the metadata file, and that's what will be consumed by the AT compiler to understand how our application is structured. Okay, so far we are good. Now we have quite a lot of files. Like to say, in this example, it's obviously a dummy example. It's like small files, so there are not so many. But actually it can grow quite a lot. And what happens there is that Nolan Lawson wrote a blog post about a year ago, more than a year ago, about the cost of small modules. So he did basically some kind of analysis, and the blog was really huge, but it's highly recommended to read that, where he found out that small modules are really good for development because you want to separate out in different kind of files. But for distribution, it's not that ideal, because there's actually a cost behind of following up all those files and getting them together. So that's why the Angular team coined a term which is called FASM, and it's nothing else than flat ECMAScript modules. So what they want to do is to aggregate everything together in one file and basically to serve that to the public. Okay, so how do we compile actually to FASM 2015? So before we did ESM 2015, now FASM 2015. Well, it turns out that Rollup is actually quite a good candidate for that. So in order to do that with Rollup, we can create such a configuration file. And it's quite simple actually. It is a normal JavaScript file. You have an entry component or an entry file and a destination file. The entry file comes from that ESM 2015 folder we just did in a previous compilation step. So we can read that from that. You can see that I reference here an NJX tabs lib demo. So that's my entry file, which we haven't seen actually before, if you didn't pay attention maybe. But if you look in the Angular compiler options section, it is already prepared for generating those flat module structure. And therefore they have a dedicated property there where you can specify a flat module out file. That should be called like this. And also flat module ID, for instance, in the way it is the name, how you can then import it in your modules. Okay, in this case, NJX tab libs demo. Okay, and then we have to specify the format, which will be ECMAScript in this case, of course. And we can again add a script tag. Now we invoke rollup. We pass it in the configuration. And if you execute that, now in the dist folder, we will get our final directory structure. We have an ESM 2015 folder there, and we have now the file in there. Okay, and you can see at the very top, the whole import statements have been aggregated together. So rollup is that kind of intelligent to also aggregate them together when they come from the same package. And below you see there is still the ECMAScript 2015 code, so we still have classes and those kind of properties we want to have. Great, check. So we now support Webpack and Google Closure Compiler. Let's see what we have to do to support also the CLI rollup and Webpack. And they require ESM, but ES5 code, not ES6 code. So let's see how to compile to ESM5. And turns out that's actually much simpler, because now we have the tools already in place. So I use here the extends property from TypeScript configuration files, which is really neat because we can use that previous tsconfig ES2015 file and import it, so we get all of those properties, and we just override those which we actually want to modify. And in this case, it's basically in the compiler options, of course, we change the target. We now set it to ES5, and also the output directory is obviously different because now we set it to ESM5. And actually, that's also something the package format specifies. Great, so we kick in again a new build task. And before we jump ahead, we simply also want to do immediately the FASM compilation. So it's like the same thing as we did before, but now for the new structure with ES5 code. Again, obviously rollup. So we can simply here copy the script over. Now in a real case scenario, you would probably just parameterize it, so to optimize a bit out. But it's much simpler to follow in this way. So I simply copied it. I changed the entry file. So in this case, it points to ESM5. The new output basically, and then the dist directory will be the ESM5 again. Format remains unchanged. Again, we add a script tag. Now let's first execute the ESM5 compilation, which we did before. So we get that ESM5 directory with all the files in it. And now let's execute the FASM compilation, and now we get the final destination file in that dist folder up there. And it looks quite similar to the one before, but now we have basically ES5 code, right? So you see the var statements there. There are no more classes which come from ES6. Okay, so second check, we're nearly done. Last step, Plunker, script tags, JSFiddle, or also Node.js. Okay, and they usually consume UMD modules. So how can we create that? Again, rollup turns out to be quite nice for that as well. So we can just take the ESM5 module we created before, okay, because they are already ES5 code, so we can take those in. And we specify as the directory the bundles folder. So the package format says the bundles like UMD should finish up in that kind of folder. We have to give it a name because UMD files are basically finishing in the global scope, so they have also had to take a name. Obviously, the format will now be UMD, right? And we have to also specify some kind of globals, which are those for Angular, basically, how they would be exposed in the UMD format. Cool, so let's add that UMD task there. We also want to minify it, of course. So we want to deploy it there, like extracted. But if someone takes it as a script tag in your browser, he should have the minified format, right? So for that, Agrify is really, really nice to use that. As you can see here, I basically use the dist bundles, which we created before from that UMD step above. And then I gave it a new output directory, a new output file, which in this case is with the min suffix. So that will be the compressed one. Great. So we run again the UMD build now. Now we run also the build of the minified part, and we get that bundles directory at the very top, where we have now two files. So first the extracted one, and then the compiled one. Everything in one line and compressed down. All right. So we supported now all of the three tools. This is also nicely prepared already, but we are missing here some files actually, like the TypeScript definition files, which we created earlier. Okay, so they are still in the temp directory, also here in the source folder. So I'm simply adding here a final script which moves those TypeScript definition files up to this directory. And then obviously, for convenience reasons, I group them all together. Like I have one build command, which is usually the usual entry point when you compile a library, and it will execute basically those steps we have just seen now separately. All right, so we can run that build command, and now we get basically the final outcome of our library. So you can see there is also the package.json files, and we have those entry files like the DTS files, and also the TypeScript definition files inside there. But you might wonder now, okay, but if I import then the module afterwards, like import steps module from nginx libs demo, how does Node.js, for instance, know which file to load, or how does the Google Closure compiler know which file to load? And the reason is we have actually missed something here, and it's these kind of properties you have to specify in your package JSON. So they define which tool is going to read which file. And you can see it points directly to our bundles directory, for instance, for Node.js, or for the module part, for like the CLI or Webpack, it points to the ESM5 part, which we have defined here. And finally, Google Closure compiler would consume the ES 2015 part. And we also specify the typings here, because that's where the language server from TypeScript will pick up with our type definitions. Great. So in theory, we are now nicely prepared. We could now start and distribute it over npm. A simple step would be simply execute npm publish on this directory, and you would be basically fine. But we really want to automate, right? So we want to automate as much as possible. We want to automate the versioning and also the deployment. So let's see how we can achieve that. There's actually a really nice library out there, and it has been around already for years. It's called Semantic Release. You can look it up on GitHub. And it has a nice CLI as well, so you can install it with npm. And this is actually a screenshot from their documentation. So you execute semantic release setup, and then basically you get asked a couple of questions where your Git repository is, you get username and kind of preparation steps which it needs to know. You can see now in the last line there's the .travis YAML file, which it also sets up for us automatically. Now, if you don't know Travis, you can find it on this URL. It's kind of a continuous integration server, which is used quite a lot, especially on open source projects on GitHub. And so what semantic release did for us is actually to set up that kind of a script file here for us. So you can see here there are different kind of sections where you specify the requirements of your library, like which node version and so on. And then we have basically the script section where we execute the build step. And it already set it up to npm run build, because that's the most common standard you find nowadays. And that will now execute our different kind of compilation steps, which we have seen before. If everything went well, then after success, the command semantic release will be invoked. As you can see, npm run semantic release. And that's something the package, so the CLI, has put inside our package JSON. So you can see at the end, there's that semantic release command. And it has a pre-step where it basically goes and determines the next version which should be released. So it applies semantic versioning, where different kind of, each number has basically a meaning, like Angular does right now as well. And it knows how to determine next version by following up with your commits. So one of the requirements here are that you use conventional commit messages, like the Angular team does and like they did already in AngularJS. And so based on whether it's a feature, so as you can see that feed prefix or a fix or chore and so on, or whether you have in your comment of your commit message like breaking change, it will know which version number to increase. That's really a nice property, because now what we can do is actually, or before that, basically I have to also hook into that process, because as you can see, it executes semantic release pre-step. It will increase the version number now package JSON, and then I'm going to copy that package JSON over to this directory again in order to have the new version number published also on npm. After that happens, it goes to the npm publish dist, which we mentioned before. So it simply picks up our dist directory and publishes it on npm. And then there are some post steps which it executes, which are basically for uploading to GitHub a change log and doing a release tag there. Okay, so with that, we're nearly set up. So one thing we have to do, obviously, and that you have to do that the first time you use Travis, you have to set up the GitHub token and your npm token, such that when semantic release runs on basically on Travis, it is able to actually publish to those kind of destinations, right? And so once we commit now, we push it up to our GitHub repository. Travis will automatically pick that up. It will start compiling by following up that YAML file, which we have defined. And if everything went fine, at the very end, you get an npm run semantic release, which will then basically do those steps we have just seen. So it will determine a new version number, and then we'll kick it up on npm and GitHub. And in fact, you can see it determined here in this case of my library, the first version 0.10. It published it automatically on npm, so we'll get a new release tag there. And it also creates, which is really nice, a new release inside GitHub. And below there is a nice changelog which even references pull requests or your comments which you did. So you have there a features list and a bug fix list if there would be any. And that's extremely nice properties, especially if you have a public repository on GitHub. You can even just review pull requests on your mobile device, and with a button click, you basically merge it into master, and that will kick off that whole automation process and publish it on NPM and on GitHub. That's really not so much time consuming. It's really nicely manageable. Okay, so let's do some considerations and wrap up. So the question you might ask now is, do we really have to do all of this by hand? Now, I've showed you the different kind of steps, really step by step, in order to know what's going on behind the scenes, because I think that's quite important in order to understand how it works. And in some cases, you might even use that kind of setup because you want to have full control of what is going to happen. But actually, there are quite some good libraries around there. So one is Human Generator, which is actually by Jürgen, conference organizer, which is a really nice package library, basically, which generates and scaffolds you out the initial structure, and you can use that and go on with that for compiling your library, for building your library. So you don't have to take care about the whole compilation process and set that up. A similar approach is another a package which emerged quite recently, which is called ng Packager. And that ng Packager has a kind of a different approach. You install it as an NPM package, and then you include it in your package JSON, and you invoke it directly from your build steps, and it will then figure out the structure of your library and then start compiling it, always following the Angular package format. So both of them actually follow them, of course. Okay, another thing which I'm really looking forward to is Angular's CLI schematics. So if you haven't seen the talk by Hans on Angular Connect, I would definitely recommend you to watch that one. Angular's CLI schematics are actually a way for extending the CLI and add your custom behavior on it. And I think that would be actually a good alternative for automating the kind of library code production, right? It's currently still a labs project, but I think we will see that very soon also in production. One thing I didn't mention actually from the beginning is actually what should go into your library. Okay, what should you bundle into your library? Well, it should be, and this is a quote from the package format document actually, it should be the smallest set of logically connected codes. You should really just put in those code which is somehow tied together and leave everything else out. Also, if you build like a UI library where you have tab components and buttons and stuff, a bit like Angular UI material, Angular material, and you should also look up how they do it actually, is you should not have one ng module which you export, and there you export everything, because then you force all of the developers which are probably just interested in the radio buttons, as Pascal showed us today, to take all of the load with them into the library, right? So you should there create different kind of ng modules and export them separately. And the Angular package format has actually a specification for that. So you should look up the document, which I referenced, because they have basically primary entry points and secondary entry points. And with that kind of way, you can manage larger libraries where there are multiple components. Cool, and we learned about today, or we have seen how to make our library AOT compatible, right? How to make it TypeScript friendly by exporting the TypeScript definition files. We have seen how to optimize different kind of tooling, so for System.js, for Node.js, for UMD, and those kind of things that it works nice in the Angular ecosystem. And finally, we have also learned what that phasm means, because it might sound quite strange if you hear it first time. And definitely look up the Angular package format. Finally, the whole automation part. Use semantic versioning. Also, if you export your library, it's a good practice to use your own namespace in front of it, like Angular does it at Angular / and then usually in the community, people have agreed to use an ngx- prefix before, so one can immediately recognize this is something that comes from the community rather than from the Angular team itself. And obviously, write tests for your libraries and automate everything out of it. So the source code for that library is online. I will tweet my talk out, the slide for the talk out later. So definitely check it out. I also created the commits in different kind of steps, so you can follow it along quite easily. And yeah, now you're free, go out and create awesome libraries for Angular. Thanks.
1-5.